You find that on page 461 in your math book. Our objectives today is to measure and draw angles of two-dimensional figures. So today we're going to be using a protractor to accurately and precisely measure and draw angles in two-dimensional figures. Now if you don't have a protractor at home, you're just going to kind of follow along with me. There are some great online math tools that you can check out, so you might want to do that and it'll help you kind of go through this lesson. So step it out. Number one, Sean looks at the instructions for building a castle model. There's a small tower at the corner of the model called a turret. Sean needs to measure the angles of an opening in the turret. How can he find the measures of the angles? Measure triangle ABC using a protractor. So A, place the center point of the protractor on the vertex of angle ABC. So remember, the vertex is where two lines meet, and that would be at our point B, and that's where you're going to place the center point of your protractor. Align, so we do that part, and they show us that in the picture. Align the 0-degree mark on the scale of the protractor with BC. So you want to make sure that line BC is pointing to the 0 on your protractor. Find where line segment BA intersects the same scale. Read and record the angle measure on the scale. So line BA, they want to find where it intersects and meets at the same point, and you're going to see that that meets at that 90-degree mark. So we're going to say angle ABC is 90 degrees. Repeat steps A through C for angle BAC and ACB. So you might want to pause the video if you have access to a protractor or the online protractor tools. If you have access to those, you may want to pause the video here and see if you can do that. So the answers are going to be 45 degrees and 45 degrees. Okay? So let's try this again, and I know this is a difficult lesson for a lot of you today, especially our 100% remote kids, so just kind of follow along with me. You shouldn't have too many of these where you actually have to use the protractor on the end of the grade. It's a test, so don't worry too much about it. All right, let's go to the next page, page 462. Step it out. Shonda's architectural plans for the Science Museum's main entrance will include a trapezoid-shaped window with two 75-degree angles. How can Shonda draw angles of a given measure to form a trapezoid? Now remember, a trapezoid is a quadrilateral, 4 sides, with only one pair of parallel lines. And if we remember parallel lines, they go side by side, but they never intersect, they never cross over. So A, place the center point of the protractor on point O. Align ON with the 0-degree mark on the protractor. And they've done that for us already. B, using the same scale, make a point at 75 degrees. So we know that if we go straight up, that's 90 degrees. So we want to try to get as close to 75 as we can, which is kind of hard to see. So we're going to go about right here, 75. And that's going to be, we're going to label this point L, and we already have O, okay? So we've done B and C. Now it says place the center point of the protractor on point N. So you're going to flip your protractor over and you're going to place it on N. Align NO with the 0, same idea. So they show you in the second illustration. Here's N, the center point. NO is aligned with 0. Then you're going to use the same scale and make a point at 75 degrees. So about the same as we did for L. And you're going to label that point M. Draw NM, which we did. Now you're going to draw a line segment LM to form the trapezoid. Okay, so remember, trapezoid is a quadrilateral. with only one pair of parallel sides, and we know that if we keep drawing line segment OL and NM, those are eventually going to cross over. So those aren't parallel, but we can say that line segment LM and ON are parallel. They're side by side. All right, pause the video and try check understanding on your own if you're able to. Sabika drew a parallelogram with an angle that measures 50 degrees and an angle that measures 130 degrees. Use a protractor to draw what could be Sabika's parallelogram. So an example of one would look something like this. So these would be our parallel lines. So if you have any questions, again, you're not going to see a lot of questions on the EOGs or the math test that have where you have to actually use the protractor in this way. So this is just a good way to practice using this tool. So if you have any questions, don't hesitate to ask your teachers.